Alright, this video is meant for my Math 8 class as they prepare for their chapter test on multiplying and dividing integers. Hopefully it gives you a little bit of a recap of the chapter and some hints for you going into the test. Okay, so this chapter is on multiplying and dividing integers, and first off we just want to remind ourselves of what integers are. And then we'll look at a few ways that we can use some different tools to help us figure out how to work with the integers. So integers are basically whole numbers, that is, that they don't have decimals with them, and we put a positive or negative sign on them to indicate where they appear on a number line. So as an example, we would have integers perhaps like plus 13 or positive 13, okay, or maybe another one could be a negative 12. Okay, what we wouldn't have would be something like positive 4.32. Okay, we wouldn't consider that an integer that has decimals in it, so we're not going to do that. So not going to include that as integers. So this is what we would look at for integers. Okay. One way that we can represent integers is by using something that we talk about as integer chips. Okay, so integer chips are basically little chips that would represent different integers. And so our textbook and other places would use a red chip to represent a positive 1. Okay, and then they would use a blue chip to represent a negative 1. Okay. Now, one thing that's handy about these chips is that they would cancel each other out. A positive 1 and a negative 1 would cancel each other out, meaning that they would equal 0 when paired together, and so we would call them a zero pair. So if we had one blue chip and one red chip, okay, they would be what we'd call a zero pair, and they meaning that it is equal to 0. Okay, so we're going to use those chips as well as number lines in this video to give you some direction on how we can go about multiplying and dividing integers. Alright, so using the integer chips, we can model multiplication. So in order to do this, we're just going to do a few examples, and hopefully you will see what it is that we're doing. So for example, we could have positive 3 times positive 4. Okay. One way that we could think of this is that it is saying that we have 3 groups of positive 4 chips, and because they're both positive, we are adding them in. Okay, so we're going to just represent that with our chips. Okay, and so we would have 1, 2, 3, 4. Okay, that would be one group of 4. Okay. Then we would add in another group of 4. Okay. And we'll do one more group of 4. Okay, so we have 1, 2, 3 groups with 4 in each that have all been added in from our chip pile. Okay, and you'll see why I'm emphasizing those words when we talk about negative ones later. Okay, in total, we can just count them all up. We have 12 positive chips, so that means this must equal positive 12. Okay, pretty straightforward. Let's try another one. Okay, suppose we have positive 3, and this time we're going to multiply it by sorry, actually we're going to do a different example here first. We'll get to something like that in a second. We are going to multiply negative 2, and we're going to multiply that by positive 3. Okay. Now, the way that we would want to set this up is by having making sure that we have enough chips to deal with. So we know if we don't regard the positive and the negative signs, we know just from, I don't know, grade 2 when we learn our times tables, that 2 times 3 is 6. So we need to know we have at least 6 to work with. So the way we're going to start is by drawing out 6 positive chips. 4, 5, 6, and that's going to go along with 6 negative chips, meaning we've got 6 zero pairs. Okay, and what we're going to do with that is interpret that we have 2 groups of 3 chips. Okay. And because this is a negative sign, instead of adding these positive 3, we're actually going to remove the positive 3. That's what that negative sign is going to indicate. So I'm going to take my 2 groups of 3 positive chips and I'm going to remove them. Okay, take them out. Okay, so we can see that they are crossed out now, and that leaves me with 6 negative chips, meaning that this must equal a negative 6. Does that work? Let's try another one. Alright, we are going to try negative 2 times negative 4. Okay, so this time we are again going to recognize that 2 times 4 is 8, so we need to make sure that we've got 8 zero pairs to start out with. So we'll draw out our 8 zero pairs. Yeah, that's right. And let's add the positive part. Okay, there we are, 8 zero pairs, and we see that they are going to be grouped into 2 groups of negative 4s. Okay, and this sign here, that negative sign, again tells us that instead of adding them in like we did in our first example, we are going to subtract those 2 groups of negative 4 out. So our 2 groups of negative 4 must be down here. Okay, and we are going to remove them, get them out of there, okay, which crosses them off, and we see then that we are left with 8 red chips, or positive 8. Okay, hopefully that is clear. Okay, you may have noticed from those examples that there are certain patterns that always follow when we have positives and negatives, and this brings us to what is called the sine rule, and we will write out the sine rule for you. Okay, the sine rule, and we're going to see actually that this rule also applies to division. So this rule applies for both multiplication and division, and basically it can be simplified like this. If the signs are the same, I'm just going to clarify, this is just multiplying and dividing. Okay, don't try to include it with addition and subtraction. That is something completely different. Just multiplying and dividing. Okay, so if the signs are the same, the answer, so either the product if you're multiplying or the quotient if you're dividing, the answer will always be positive. Okay, so this means that positive times positive, the signs are the same, positive and positive is equal to positive. It also means that negative times negative, again the signs are the same, that means that equals positive as well. Okay, The second part of the rule then, you might be able to see, if the signs are different, okay, the answer will be negative. Okay, so quick example there. This time we'll use division. So if we take a positive and we divide it by a negative, okay, signs are different, right? Got smiley faces going on here. The answer must be negative, okay? Or alternatively, if you had a negative and then you divided that by a positive, again the signs are different, so the answer must be negative. Okay? That is the sine rule. If the integer chips are not working for you, that's okay. The sine rule will also help you, and as you get more comfortable with it, this is probably the rule you'll end up using. It makes things go a little bit faster. Okay, we're going to move into division now, and we're going to show you one technique with division. We could use integer chips as well with division, but I'm going to show you the use of a number line for division. Okay, so we'll do that on the next slide. Okay. We can use a number line with integers, particularly with addition and subtraction. This is something that we do quite often, but we can use it with division as well. So I'm going to show you just a couple examples, okay, that we can use a number line for. So I'm going to give you an example here of positive 12, and we are going to divide positive 12 into 3 different parts. Okay, so I'm going to draw on my number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's positive 12. And remember, when you learned addition and subtraction back in grade 7, you would have hopefully learned on the number line how to do this. We start with the first number, drawing out an arrow that represents it. And remember, on a number line, positive's to the right, negative is to the left. So you start with a dot at 0, and we're going to draw an arrow going over to 12. That arrow shows us the direction that it is a positive integer, and we're simply going to divide it into 3 equal things. So if we do that, we will see that this is one segment. Here's another segment. We've divided it into 3, and each of those segments, okay, each of those segments is positive 4. Okay, a value of positive 4. So this means that this must equal positive 4. Okay, that one hopefully isn't too hard. We will try one that's maybe a little trickier, and that will be negative 15, and we are going to divide that by positive 3. Okay, sorry, that didn't show up. Positive 3. Okay, so very similarly, we will draw out our number line. Okay, I'm anticipating the direction here, so I'm going to put my 0 over here, and we're going to go 5, 10, 15. Okay, you would obviously be much more careful, probably use a ruler to get the spacing right on this. Okay, and we would draw an arrow in the direction of our integer, so negative 15 going this way. We're going to split it into 3 even sections, and we're going to see that each of them represents a negative 5 value. We're going negative 5, negative 5, negative 5. Okay, which means that this answer must be negative 5. Okay, now number lines can be handy for that, for switching it up and that sort of thing, but sometimes the signs are still a little bit confusing. So at that point, I would suggest to go back to our sine rule that we did on the previous slide here, and remember that when the signs are the same, answer is positive. When the signs are different, it will be negative. Okay. All right. Very last thing, quickly, we have to remember that when we see integers, just like any other part of math, we must use the order of operations. So we remember that we've got brackets, then exponents, then division and multiplication, and then addition and subtraction. Okay, BEDMAS. Quickly do one example of that, just to recognize that we need to consider that. So we will take a -6. We're going to subtract -9. Okay, and then we're going to add a -14, and finally divide +2. Okay, so looking at this, we're tempted to start from left to right, but we need to see that if we go through, the first one on our BEDMAS order is this division statement here, so we need to start with that -14 divided by 2. We can recognize that we've got different signs, which means it must be negative. 14 divided by 2 is 7, so it's a -7, and we can rewrite this -6 minus a -9 plus a -7, and now we've got all addition and subtraction, so we just work left to right. Okay, left to right, -6 minus a -9, minus, or subtracting integers is like adding the opposite, so -6 plus 9 plus a +9 becomes a +3. Okay, we're going to take that +3 and add a -7, which brings us back to -4. Okay, and that would be your answer. So remember, order of operations does apply. Alright, that is all for multiplication and division of integers. Hopefully that is helpful. Thank you.
Made with Doodlecast Pro.